Lifting with magnets. What does a strong magnet do to iron? Attract it. What if we could use magnetism itself to raise parts of the Titanic wreck? By attaching powerful electromagnets to the Titanic's ferrous hull materials, she could be lifted off the bottom using magnetic force. This futuristic method offers a non-contact way to retrieve pieces of the disintegrating liner. However, the realities of implementation, especially at extreme ocean depths, severely diminish its feasibility. The basic premise centers on using large salvage electromagnets to attach to and pull upwards on iron and steel components of the wreck, such as hull plates and structural framing. These water-tightened electromagnets generate powerful magnetic fields when electrical current runs through them. In theory, the magnetic attraction force could provide enough lift to raise some wreck fragments despite their scale and weight. Yet therein lies the first technical barrier: generating magnets with enough raw strength to physically lift multiple-ton pieces of a shipwreck from thousands of feet down. The extreme water pressures and corroded, pitted surfaces down there necessitate magnets with outrageous field strengths and massive power draws. Their electrical cabling must also be super reinforced to avoid rupture when lifting at full power. Additionally, the magnets must be capable of selective attachment and quick release. Randomly grabbing pieces of the Titanic's deteriorating structure could damage fragile remnants or entangle cabling across the debris field. The magnet controller systems must allow for fine detachment and reattachment, even when supporting heavy wreckage upside down in total darkness. This degree of precision control at extreme ocean depths poses its own challenges. There are also risks specific to lifting actual shipwrecks. The Titanic's structural integrity is severely compromised after a century on the seafloor. Magnetic lifting stresses could cause unintended corrosion fractures or even detach rivets and collapse plates. Sudden shifting or collapse of wrecked debris while lifted could also snap cabling and bury or entangle the electromagnets. These hazards only intensify the deeper the operation is conducted. The concept of surgically lifting pieces of the Titanic wreck using selectively applied magnetic force is genuinely compelling. Unfortunately, the realities of cobbling together extreme water electromagnets, powerful yet precise enough to mechanically hoist large masses of disintegrating shipwrecks from thousands of feet down, are stacked heavily against this futuristic salvage method. Number 7. Lifting wreck in parts. Imagine a massive underwater operating room equipped with intricately controlled robotic scalpels and saws. The patient, the decaying wreck of RMS Titanic. The objective, to meticulously dissect the historic ocean liner into segments and lift each section independently.